Hello, my name is Brandon Hall, and I am the team lead for the senior design team.
My name is Quinlyn Scully, and I'm the software lead of the senior design team.
I'm Conan Clifford and I am the hardware lead for Motor Doctor.
Hi, my name is Parker Daniel. I am the motor controls lead for Team Motor Doctors.
I'm Wesley Hallum. I'm the harnessing lead for Motor Doctors.
Formula SAE is a student design competition in which teams design, build, and race formula type electric vehicles in competitions governed by set rules and was created by SAE International. The UAH MAE and EE senior design classes have expressed an interest in this competition where they work in tandem to develop a electric vehicle. And shown above is what the vehicle looks like this semester. And now for a brief overview of the components chosen by previous teams on this project, as well as our team.
So this is our vehicle control unit, or VCU. This is going to be the brain of the entire system. Now, we weren't able to get it in time, so what we did was we rescoped our project to where we would do the preliminary work to set up next semester's team for success, like the wiring. So this is a water-resistant housing for the VCU that houses CAN bus and sensor connections. This is our inverter, which converts DC power from the battery to AC power to the motor of 300 amps RMS and 50 to 400 volts DC. This is a 12-volt low-voltage source to power the coolant pump and resolver. It's grounded to the motor housing to simulate a chassis ground, and it establishes a common ground for all components. This is the accelerator pedal position sensor. It feeds pedal position information to our controller to make sure that the pedal is operating in agreement with actual acceleration.
Part of our project scope was to provide thorough documentation of setting up the system. These videos can be found within our project Google Drive for future teams to reference. But for the sake of this video, here's a quick overview of the project setup for testing purposes.
So for this part, we're going to connect the J2 header. This consists of the resolver as well as the 12-volt power system. First, connect the 12-volt power system to the test bed, and then you'll connect the 8-pin Deutsch connector to the resolver. Here, we're connecting J1 to the top part of the inverter. This is just to the test bed. For this, we're making connections to the microcontroller to variably control the speed. This was used in substitution for the VCU because it had not arrived yet. This was connected to the analog input and then to a 5-volt power supply. At this point, you should connect each of the 3 phases according to the color on the tape. Connect each of the A, B, C phases accordingly. Then connect the common 12-volt ground to the test bed, the power supply, and the inverter, as well as the microcontroller. This is to ensure proper voltage from the microcontroller, the test bed, and the inverter. So here you're going to use a Y cable connection to create a high voltage test bed battery. So this is a high-level overview of the entire system connected together. One thing that was not previously mentioned was the pump. The pump should be connected to a 12-volt power supply with a 15-amp fuse due to the fact that it's rated at 17 amps and a 17-amp fuse wasn't available at the time. Now here's a demo video in project implementation. So for this was the accelerator pedal position sensor test. We can see the counts variably change. We use the same principle for the counts to find the RPMs and get the GUI software. This was done by looking at the counts and the motor RPM.
As we can see through the demo video and AEM cal display for the accelerator pedal position sensor, project scoped was achieved. We would like to thank our sponsor, Dr. Ginga, for guiding us through the semester, for ordering parts, clearly defining project scope, providing helpful feedback and suggestions, and being very kind. Also thanks to Mr. Height for the guidance and suggestions he provided throughout the semester. We wish the best of luck to the future FSAE EE senior design teams. Motor Doktors signing off.